You see, we have route path selection. We used the attribute weight in our previous class, but this is not for all the destinations. For just 2.2.2.2, we want to take another path other than the default path. Now, what is the default path? Default path is the lower path, path via 7. To reach 2.2.2.2, which is here, to reach 2.2.2.2, which is here, it goes this path. It takes this path. That is the default one. Our aim is only for 2.2.2.2 you go this way, and for other destinations like 1.1.1.1 the default path, 3.3.3.3 the default path. We have achieved that by using a route map. This is the route map. I'll come back to this route map. I'll show you what we have achieved. Show IP BGP. You can see that only for 2.2.2.2 only for 2.2.2.2 it is going via 8. You see the address, the last number in any address is the host name of the router. 89, 89, 89, 8. Whereas for 1.1.1.1 it is going via 7, as well as for 3.3.3.3. Let me show you the routing table. Show IP route BGP. You see, for 111 it goes via 7, and for 333 it goes via 7. 2.2.2.2 is in the same autonomous system where you have 3333 and 1111, but it goes via the upper path. How is this achieved? Show IP BGP again by setting high weightage. Even though the autonomous system jumps are more compared to this one, it prefers to go via this path with the higher autonomous system path, large autonomous system path. It is because of a weight attribute. Weight comes before any other attribute. After next hop is the weight. Weight is the very first attribute. So, how did we achieve this? We wrote a route map to match that IP, the destination 2.2.2.2. In this prefix list, 2 dot is the name of the prefix list. I have that 2.2.2.2/32. That I call and say if this matches in any update given by router 8, then you set 45 while accepting from 8. So when it accepts from 7, it will not add 45, it will be default 0. The same update when it comes from 8, it gives 45. When the update is coming from 7, you see, when the update is coming from 7, it has not added the weight. But when the same 2.2.2 update given by 8, it has added 45. As a result, that path via router 8 became a best path. And now we need to write another route map with the same name. Name of the route map is for 2.2.2.2. Write another route map with the same name and put the sequence number, any number after 10, and just come out of it. That is to allow the other updates without any modification. See, if you don't give this one, you would have not received all these updates. Only this you would have got. So we have to write. Let me remove this and show you. Wait, I'm going to remove this and show you. See what happens. Show run section route map. I'm removing this route map with 11 sequence number. And now I am going to clear BGP. Then you will see how the impact if you don't have clear IP BGP star soft. Show IP BGP. Now let's do how to say clear IP BGP star. Show IP BGP. Now you see all that comes from 7, it is coming. But from 8, only this 2.2.2.2 is coming. But 1.1.1.1 should also come from 8, you see. It's not now accepted. 3.3.3.3 should also come from 8. But now you don't see those things. The reason is implicit deny kind of thing in route map. So when I put this, and refresh, now you see, okay, wait some time, it will come. Clear IP BGP star soft. See? Now 1111 is also coming. See the compare and see. See the difference. This one 1111 coming only from 7. But here it is coming now both from 7 and 8. This one did not match with the route map sequence number 10. It matched with route map sequence number 11. Any question? Did you understand why we write another route map?
Sir, no sir, I didn't understand sir.
Super. What about others?
Sir, explain one more time.
Okay, others? I am repeating this for you. Listen very carefully. 1.1.1.1, 2.2.2.2, 3.3.3.3. These are the three networks from autonomous system 10. Now, these three networks are not only advertised in one path, it is advertised in all available paths because you have neighbors. So router 2 also advertises, router 3 also advertises, router 4 also advertises, router 5 also advertises, router 6 also advertises, router 7 also advertises, router 8 also advertises. Listen carefully again. Now router 9 is learning this from two source. Router 9 is learning this three networks, same three networks from two source, 7 and 8. Now for router 9, which path is best? You tell me. To reach this three network, which path is best for router 9 and why?
Clear ke path sir. 30, 50.
Via 7. Why?
Yes. Yes.
Shortest AS
This
path.
is
Shortest AS path. Very correct.
yes sir.
Anbu, do you agree with this?
Yes, sir.
Okay.
Shortest is.
Now router 9 knows both the path. In router 9's database, you have both paths via 7 and 8. But in the routing table, you will have only route via 7. Now, you want to tell router 9 that when you receive the update, when you receive this update from this fellow, where I have said that fellow, you see, this fellow, when you receive the update from this fellow, you understood the fellow now? Come on, sorry. When you receive the update from this fellow, you do this. What you do? What the route map says. What does the route map says? Route map says in the update that is coming from this fellow, if the prefix list matches, for that I am going to give 45 weight. What is there in the prefix list? 2.2.2.2 is there. So, when this fellow advertises, two fellows are advertising here. 7 fellow is also advertising and this fellow is also advertising. You have said when this fellow advertises. Only for 2.2.2.2 you add 45 weight. Only for 2.2.2. All the rest, see, all the rest you simply permit. Whatever.
So sir, which means 1.1.1 and 3.3.3, it's by default it is permitted.
Correct. Because you wrote this line.
We are defining 2.2.2.2 only.
Yeah. If you did not write this line, if you did not write this line, 1.1.1.1 and 3.3.3.3 will not come in. Will not come in. Because you wrote that line, it comes. And now you see, I have also said in. Why? When this fellow gives me, it comes in. I'm here. When the update comes in from that fellow, match 222, set weight 45. For the rest, who are the rest? 1.1.1.1 and 3.3.3.3, you just accept it without any change. You understood now? So, yes, question. Please
சார்
ask
ஒன்றும் இல்லை
question.
சார். இப்போ நம்ம அந்த இன்புட் டிராஃபிக் அவுட்புட் டிராஃபிக் இன்டர்ஃபேஷன் நம்ம பார்க்குறோம்ல சார், அதை வந்து நம்ம எப்படி சார் இன்புட்டை வேற ஒரு ரவுட்டருக்கும் அவுட்புட் வேற ஒரு ரவுட்டருக்கும் நம்ம டிராஃபிக்கை டிவைட் பண்ணி அனுப்புறது, அதுவும் இப்போ இல்லை, நீங்கள் கம்மிங் கிளாஸில் கூட அதை சொல்லிருக்கீங்க சார்.
Okay. So your question is incoming traffic, outgoing traffic. Incoming policy, outgoing policy. What we have seen now is outgoing policy. Wait, by using wait you can impact the outgoing policy. If you want to impact the incoming policy, when you advertise this network 1.1.1.1, when you advertise, you need to do something so that the traffic will not come this way, it will come this way. That is inbound. We will see those things later. Now we just started attribute and we are in the very first attribute called wait.
ஓகே சார்.
And with this attribute we learned how to impact the outgoing traffic. See, one thing you need to be very clear. Update is coming in, using which the traffic is going out. You should not get confused with both. Because I have said in, whenever the update comes from router 8, it is going to add 45 wait it is going to add 45 wait. That makes BGP to consider this as the best. See, greater than symbol means what? Best. Star means valid. So whichever is best, only that will be there in the routing table. You see? So whichever is there as the next hop in the routing table, that is the path it is going to take. So in our topology, you see 89 is the upper path. So traffic will go that way. Let us trace route and show you. I'll trace route and show you. You see, it goes via router 8. Alright, I know why it is showing star. I should have sourced with 9999. I didn't do that, that is why. Okay, so we have seen why wait is making the path to go via 8. The reason is AS path comes after wait. Wait is the very first attribute, and we have seen wait both using route map and without using route map. I have shown you both. If I use route map, I can say only for 2222 I want the traffic to go via 8. That can be possible only when you use route map. When there is no route map, then for all destination you can push the traffic via 8. If you say I do not want to use route map, then you will be attaching that weight with the neighbor 89, 89, 89. So whatever neighbor has given, for all the network, weightage will be 45. So I want to repeat. When do we use route map? Whenever you have one or few networks to go via the other path. When do we use without route map? Weight can be used without route map whenever I want all to go via 8, whatever router 8 gives. I want to give high weightage and I want to send all traffic that 8 can take me. I prefer 8 instead of 7. That's the time I will use wait globally. I showed you in the previous class. All right. I can also show you one more time when this finish. Now let's do that one also one more time. I'll remove the route map, router BGP, no, show run section router BGP. Okay, now I'm going to remove the route map which we have written, and we are going to use wait without route map. See this route map? I removed. Now I say instead of using route map, I say neighbor 89, 89, 89, 8, wait. Straight away, wait 45. So this is going to apply 45 for all the networks that are advertised by 8. So 7 is also advertising, 8 is also advertising, but 8 has got more weightage. Clear IP BGP star soft in show IP BGP. You can see 45 not only for 222, even for 111, because 111 is also coming from 8. For all, if this is what you want, then you can put globally like this. Globally like what? I did not use route map. I straight away went say whatever this guy is giving, whatever this fellow is giving, whatever this neighbor is giving, whatever this peer is giving, just give more weightage. And now if you check the routing table, all will be maximum will be going where router 8 except 777. You see, all next hop has got what? 8, 8, 8, 8, 8. If this is your need, then you no need to use route map. No need of prefix list. No need of access list. Okay, now let us go and remove all these things from router 9, and we are going to local preference. From router 9, I'm going to remove all this. Router BGP 70. Whatever I have configured, I removed. And now I'm going to clear after clearing show IP BGP. You can see now everything is default. Mostly all the traffics are going where 7 due to the shortest AS path. Now show IP route BGP, you see mostly except 8.8.8.8, which is very close, except that all the rest are going via 7. Okay, now let's go to the autonomous system 10 and see how the traffics are going from router 1 show IP route BGP, focus on 99 and 999. Both are going via router 3. Both are going via router 3. Let's go and check on router 2. Show IP route BGP. Even here 9999 and 9999 going via router 3. Of course, router 3 will also go via the same. Router 1 and router 2 is going via router 3. So router 3 will go via which way? this AS30, correct?
Yes, sir.
Hello. Now, our aim is to send all traffic to 9999 and 9999 and 7.7.7.7 via upper path, you know upper path. But not only for one router, for all router in the autonomous system should go via the upper path. So what I can do is I can go to router 2 and say router BGP, wait a minute, show IP BGP. You see, for 9999 and 9999, it is learning from two different sources. Okay, so what I'm going to do is I'm going to prefer this source. Right now it is preferring this source. See the below greater than symbol. Right now it is preferring this source because of the less AS path. But I'm going to make this by setting local preference. How? Router BGP 10, neighbor this fellow, neighbor this fellow, local, okay, sorry. The command is default local yeah, this command is very weird. BGP, we are already inside BGP. I don't know why I should type again BGP. It is okay. BGP default local preference. You see, this is little abnormal, right? Okay, I'm going to set local preference. This router local preference is 400. So now if you go to router 1, if you go to router 1 and check show IP BGP, okay, let's clear IP BGP star soft. Also on router 2. Whenever you do some changes to the attribute, you have to refresh. Clear IP BGP star soft. Okay. Now go to router 1 and check. Look at this, 400. So now all the routers in this autonomous system will go via upper path. Do you see? Last time what was the path? Lower path, 3333. Now it goes via upper path, but I configured where? Not on router 1, on router 2. So even router 3, if you go and check,
So
even router
local preference வந்து within
autonomous
AS
system,
நால நம்ம அந்த எந்த எந்த AS ல வேணா அதாவது one router 1 to 3 router எங்க வேணா
any
நம்ம
router, any router. So you see router 9, router 3 says to go to 999, I have two paths, but I prefer to go via the path with the local preference 400. You see, even though the AS paths are too long, it prefers because of local preference. So I just showed you how to set local preference for all destinations. Not precisely by writing a route map. I said for all destinations that router 2 can take, router 2 is the best for us. I'm telling the whole autonomous system, anything router 2 can take, he is the best. You no need to worry about other path. Anything router 2 can take as prefer router 2. Alright, so the entire autonomous system now follows the upper path. Let me trace route and show you. I'll trace route and route. See, router 3, this is very short, but it won't go this way. It will go via the upper path because of the local preference. Trace route 99999 with the source 33333. It will go to router 1 and then 2 and then 4 and then 6 and then 8 and then 9. You see, it goes via the upper path. Do you agree?
Yes.
Okay.
Okay, sir.
Now, we will be using route map and sending the traffic only to 9999 via the upper path in the next class. I want you to do up to this level with confident you come so that we can do something bigger. First, you get a confident of what a roadmap does, when to use roadmap, where to use wait, where to use local preference, all the stuff.